Hello, and welcome to your first video of Chem 1. And this video will follow your notes. So if you want to get out your notes and follow along, that would probably be helpful. But these videos, I try and keep them as brief as possible. So I typically only cover one topic at a time, okay? And as you might remember, Unit 1 is all about just what do you need to know to be successful in this class. So we're going to just cover some basics. Some of the main topics, we'll talk about significant digits, or something I call sig figs, and that's what this video will cover. This unit will also cover dimensional analysis, which is really important. We use that a lot in chemistry. Uncertainty and precision and how they're related to each other. We'll talk about some basic measurements, how you make different measurements with different equipment. And finally, this unit will cover a series of academic language. In other words, we're going to have quite a bit of vocabulary in first year chemistry, and I just want you to be aware of what's expected out of those in the short answer tests that you have. Okay? So for this video, again, the only topic I'm going to cover is significant digits, and I will save scientific notation for another day. Okay? So this idea of significant digits, or sig figs, comes about, well, actually it's a model or a set of rules that lets you know how many numbers to write down for an answer when you're calculating something. So just because your calculator gives you 8 decimal points in an answer doesn't mean you write all of them down. There are rules. So the reason why we have significant digits is because if you're calculating data from equipment, okay, data that you have gathered and observed and written down from equipment, you can't calculate something more precise than the equipment that you were using. So in other words, if I have a meter stick, okay, and I measured this, okay, I can't have a calculation then that goes out farther than those 3 digits. I hope that makes some sense, but I'll talk a little bit more as we get a little further into this. So significant digits, or sig figs, the first thing you need to know is what is considered significant. And then we'll look at how to apply them in calculations. So my first rule I have here for significant digits is any number from 1 through 9 is considered significant. So I'm going to put here 123,456. Every single one of those digits in that number is significant. So this number has 6 sig figs in it. Okay, pretty easy. Now where it gets a little more sticky is when we're talking about zeros. Zeros are iffy. If they are between numbers, they count. Or in other words, they're significant. So my example is going to be 1009. Okay, these 2 zeros are in between the 1 and the 9 and therefore important. So this number has 4 sig figs in it. Okay, hopefully easy so far. My next rule here is left of a number. So if I have zeros to the left of any number, okay, let's say it's, let me get rid of that gap here. Let's say it's 00.0456, okay? Those zeros to the left of that 4, here I'm trying to highlight it, right? To the left of that 4, right there, those don't count, okay? I'm trying to highlight this, sorry. There we go. All right, those don't count. They are to the left of a digit, okay? So this number only has 3 sig figs in it. Okay, let's look at, let's see, just slightly different here. That one right there, notice that the 0 is just on to the left of that decimal point. That guy doesn't count either. So this number, also 3 sig figs. So just what I wanted you to see here is it doesn't matter if the 0's to the left or to the right of the decimal, but if it's to the left of the number itself, they don't count. All right, next rule, right of a number with a decimal. Okay, to the right, let's see here, 345.605 or 6, okay? No, let's take that one off. There we go. All right, 345.60. So if you remember in your other science classes, when you talked about doing measurements, you probably remember that when you're measuring something, you're supposed to write down every single number that you know for sure, and then you're always supposed to include one uncertain digit. In other words, when I measured this 345.60, I knew the 3, 4, 5, and I knew that 6, but that 0 was an estimate, okay? A good estimate, but I only write one of those. That is the precision, that 0 reflects the precision of that equipment and therefore counts. So I have 5 significant digits in that number, okay? Let's look at, how about 1200 point, okay? Or even another 0. We could even add another one. All of those zeros count, only because I put that 0 there. So I could say something like 1,200 people came to the concert last night, okay? And I counted them. There were exactly 1,200. So that one has 4 sig figs in it. But let's say, I didn't exactly count all the people. This is my last rule here. Let's say I estimated that 1,200 people came to the concert. Notice I don't have a 0 or a decimal point here. And because I don't, those 2 zeros are not significant because I estimated. I didn't really count them, so I can't really include them in terms of being significant. So this number, only 2 sig figs. Okay, the 1 and the 2 and not the 2 zeros. All right, so let's move on with this because these are just the basic rules and you have to know the rules to use them in calculations. So my next part is, what do we do when we have to add, subtract, or multiply these numbers? So when we're doing significant digits with adding and subtracting, we have to look at something called the least precise data point. So here's what I mean. Let's say I'm measuring the length of 2 objects in my classroom, and I'm going to add them together. And the first time I make my measurements, I'm going to measure with a meter stick. Okay, so this one's made out of a meter stick. And when I use that meter stick, if you've ever used one before, though that 3 and that 4, I knew for sure, and I estimated because the length of the object was between the next 2 lines. So I estimated it at a 5 there, okay? So the next object that I'm adding to this, though, is much, much smaller. Let's say I had to use a ruler for this one, but my ruler has more lines on it. So I'm allowed to go out more digits because that ruler is more precise than the meter stick, okay? So when I add these 2 things together, okay, my calculator here, let me get down here. So I'm going to put all this in my calculator, right? 0.345 plus 0.0451. Okay, and my calculator tells me that it is 3901. Okay, the only thing is this number isn't correct. Okay, because if I estimated, let's go back up here to my meter stick measurement here. If I estimated that 5, I sure as heck don't know what that next number is. It's a mystery to me, and that also means this number down here, I can't include it, right? Because if I don't know it here in this decimal point here, I can't possibly know it in my answer. So I'm going to leave it off. So again, least precise. My meter stick was my least precise piece of equipment. It only went out 3 decimal points. My ruler went out 4, but my answer can only have the least amount, which is 3. Okay, let's try another one because you also have to do some rounding here. So let's say I'm adding 3.455. Let me go back to black here. 12.455 plus, let's go 3.51. Okay, and again, this is what I want my calculator. I'm going to put this in my calculator here, and 12.455 plus 3.51. My calculator tells me it is 15.965. Okay, again, this top number here goes out 3 decimal places. My bottom one only goes out 2. And again, that 1 must have been estimated, so I don't know that next digit, which means I can't include that in my answer. So I'm going to put that one as red. So I'm going to cut off this answer between the 6 and the 5. Now the only thing is that being a 5, I know it's at least a 5. I don't know what this one it was, but I know it's at least a 5 or higher, which means this must round up. So this number then becomes 15.97. Okay? So again, I go to the least precise, but then I look at the one digit to the right and see what that number is. If it is lower, 4 or lower, then this remains the same. If it is 5 or higher, then it is going to round up. So those are the rules for addition and subtraction. They pretty much follow the same thing. The next thing I have is multiplication and division. And these have totally different rules. Okay? Multiplication and division is not about precision as it is the least number of sig figs in a data point. Okay, so let's get out some more examples here. Okay, let's say I have 12.05 times 3.2. Okay, and again, I'm going to get out my calculator. Okay, and my calculator says 12.05 times 3.2 is 38.56. There we go. Sorry about that. 38.56. All right, so these are different rules. This isn't about precision. This is about number of sig figs. So 12.05 has 4 significant digits. That 0 counts because it's in between. 3.2, this number, has 2 sig figs. So my answer has to be the least amount of sig figs. So this answer has 2. I have to cut it off between the 8 and the 5 here. And because this is a 5, right here, this is going to round this answer up to 39. Okay, let's try it one more time because these can get kind of difficult. Let's say I am taking, let's do a division. 12.45 divided by 2. Okay, so 12.45, I'm going to stick that in my calculator, divided by 2, and my calculator says 6.225. Okay, again, the least number of sig figs, I have 4 here. I only have 1 here, so my answer can only have 1 significant digit. So I have to round this all the way down to 6. All right, again, I'm going to just kind of flip back here, and I'm going to wrap this up real quick. Please remember, adding and subtracting, your rules are a bit different. They can get tricky, and I'm going to throw one more at you just to make sure. I'm going to go back to my concert analogy and say that I estimated 1,200 people showed up for the concert. But towards the end, I counted another 35 that went into that concert hall. Okay, so I'm going to add these two together. Now, with significant digits here, you're not going to get what you expect because your calculator is going to say 1,235 people are in there. But remember, if I estimated those 2 zeros, I don't really know that these 2 numbers are a 3 and a 5. So I actually go back to 1,200. I know, it's weird. I think you'll get used to it. It does take some practice, but please know that sig figs are here to stay. There's something that we use throughout science, but chemistry in particular, because we're always making lots of measurements and calculations. So please, please, please ask me questions if you need to, because I don't want this to cause a problem in the future. Okay? All right, I think we're done with this lesson. Take care, and I will see you soon.